I'm going to talk some basics on nano structures. So nanotechnology. So nowadays nanotechnology is getting too much importance. So there are lots of TV advertisements featuring nanotechnology. I have listed something. Samsung introducing an air conditioner which uses silver nanotechnology, and nano paint, and Sachin Tendulkar advertising Techno Bright washing powder which uses nano enzymes. And below two images are from two different films. One is G.I. Joe and another one is Transcendence. One film they use nanomites to destroy this world. Another film they use the same nanotechnology to save the world. From the people who produce washing powders to the people who save the world and destroy the world, they speak about nano. They want to speak about nano. So what is so special about nano? So what makes every people talk about nanotechnology? There are two factors which make nanotechnology so special. So first one is increase in surface area. What is increase in surface area? I can give it with a simple example of cooking a potato. So what are the steps involved in cooking a potato? Step 1, you wash it. Step 2, you cut it, and then you boil it. So why do you want to cut a potato? Instead of cutting a potato, you can directly boil a potato, right? So why do you want to cut it? So when you cut a potato, you are increasing the contact of boiling water with the potato. So which means that your cooking speed is fastened up. So that is just by cutting the potato, you can increase the speed of the cooking reaction. I can say that increasing surface area is increasing efficiency. But how much is the efficiency is increased? So that I can give you with another example. You take a cube with the side of A. You have to calculate the surface area of this whole cube. The cube has 6 square sides. One side is A square and 6 sides it is 6A square. So now I am going to cut this cube on 3 ways. So you have 8 smaller cubes with a side length of A by 2. And just calculate the surface area of this individual cubes. 6 into A by 2 whole square. Then you have 8 cubes multiplied by 8. What you get is 12A square. Just by cutting at 3 sides, I am increasing the surface area by twice. 6A square becomes 12A square. What if I cut the same cube millions of times and I make it to nano size? So how much increase in surface area I could attain? So I can do a reaction that can be done by 1 gram of gold in 0.01 gram of gold. What's the value of 1 gram of gold? That is 3,000 rupees. I can do a reaction which can be done at 3,000 rupees at 30 rupees. But currently the cost of producing nanomaterials is very high. But as the industries or lots of industries are coming into the field, the prices keep on reducing. But after 5 or 10 years, you will get very cheaper nanomaterials. You can do lots of cost cutting using nanomaterials and with high efficiency. What is the second factor? That is change in properties. So you can ask me a question whether if the things are made into nano, they change in properties or not. I say it is yes. But why the properties are changing? I can give you the simple example that a student sitting in a class, so with a staff, with a faculty member standing and lecturing you, how well obedient you will be sitting inside. The same student when the faculty goes outside of the room, how the students will be there inside a classroom. So similar students, when 5 or 6 friends hang out together, how will you behave? Similarly, when 2 close friends go out, how will you behave? The same Ram or Sita is sitting all the 4 scenarios, how differently they behave? Because the influence of the surroundings is reduced on you. That is, the faculty member is a force acting on you, and the rest of the class is acting on you, rest of the friends is acting on you. So when the external force is reduced, you behave, that is, you show your original face. So that is going to happen in the same thing is going to happen in nanotechnology. When a bulk material, there are billions of atoms and each acting on each other, pulling each other. So they cannot freely react. But when you make it to nano size, there will be around 1,000 or 10,000 atoms. So you're making up from billion atoms to some 1,000 atoms. So the influence of other atoms is reduced. Once the influence of other atoms is reduced, you behave differently. That is the original nature of that atom. Not only the influence of surroundings is playing a role, there is one more thing that is called quantum confinement. Don't get afraid of the term quantum. I'll explain you with another simple example. So what is quantum confinement? So you have a bulk material, you have an electron, and this electron is free to move everywhere. But the same material, I am compressing it from the one side. So the Z direction I am compressing. So I make it into a thin film. So now the same electron, where the electron can move? It can move only in the X and Y direction. The Z direction of the movement of electron is restrained. So that is, you are constraining the electrons only to the two dimensions. What if I again make it into a small nano wire? So this nano wire, you have the same electron. How it can move? It can move only in the X direction. So the Y and Z directions are confined. I make the same wire into a small dot. That's called a quantum dot. The same electron cannot move anywhere. It is restrained. Such a way, I am restraining movement of the atoms, which make them behave differently. So these are the two things that make nanomaterials change in properties. One is quantum confinement, and that is restraining the movement of the electrons. And the second one is the influence of the surroundings is reduced on the particular atom. So that's why things are behaving differently. So how things behave differently? What are the changes that can occur? So electrical properties, mechanical properties, optical, physical and chemical properties. This picture, you can see a lot of bottles with different colors. Everything is gold, but different nanometers of gold. So same gold at different nanometers exhibit different colors. And you would have heard of the term carbon nanotubes. These carbon nanotubes are excellent material just made of carbon, which are 25 times higher electrical conductivity than copper and higher strength than steel. A simple carbon, when made into a carbon nanotube, they can behave ultimately different with excellent properties. So why do you need these excellent properties? Because we have lots of problems. There are oil crisis, medical problems and pollution, lots of things are there. You need a solution to solve everything. So with existing technology or existing property of materials, you cannot solve these things. These nanomaterials can give you that excellent properties and solve everything, solve lots of problems. Every time you come across nanotechnology, you will also hear a scientist's name, Schrödinger. And whenever you talk about Schrödinger, you will come across another frightened term called Schrödinger's equation. That is one animal's name associated with this scientist. That is a cat, Schrödinger's cat. This is a peculiar analogy where you lock up a cat in a soundproof, opaque, vibration-free chamber with a small beaker of poison. You close the door and you have to find whether the cat is alive or not. The cat may have took the poison and died, or it may live. But how do you find whether the cat is alive or not? You cannot go near the box and say meow, it can cry back. You cannot do anything to see. Only way is you can open the door and see whether the cat is alive or not. But I have placed a small bomb on the knob of the door. Once you open this box, it will burst and the cat will definitely die. That is called the influence of the observer. Once you see, the cat is dead. But if you are not seeing whether the cat is alive or not, how could you find it? That is nanotechnology. There is one way you can just toss a coin. If you get head, the cat is alive. If you get tail, the cat is dead. Instead of tossing a single coin, use 1,000 coins, give it to a computer, make it toss and find whether the cat is alive or not. And this is the same thing that's happening in nanotechnology. It is very way to study what things we know. 1 plus 1 is equal to 2. We know that. That is not interesting. But when you come to nanotechnology, you may say that 1 plus 1 is equal to 0 or 1, or it may be even 2. So that is nanotechnology. When you learn about some things that you don't know, that makes that thing really interesting. And nanostructures or nanotechnology is one such excellent, interesting area where it will keep you always puzzled. Thank you.